Welcome back once again to Math Concepts. We are going to talk about tautologies and contradictions in this video. Now, a tautology is a statement that is true all the time. It's a statement that is true regardless of the truth value of the component statements. So no matter what you put in, a tautology is always going to give you a true statement as the output. A self-contradiction is kind of on the opposite extreme. A self-contradiction is going to give you a false statement regardless of the inputs of the various component statements. And the way we can determine whether a statement is a tautology or a self-contradiction is by looking at the truth table. So this is going to be another video that involves truth tables. They are pretty fundamental to understanding logic. So we've got quite a few videos that involve these truth tables. So we'll go to the document camera and look at some examples of tautologies and self-contradictions. So the key ideas here are being able to recognize whether a statement is a tautology or a self-contradiction. Now, as far as the truth table goes, you can tell a tautology by looking at the last column. If the last column is all true, then you got a tautology. If the last column is all false, then you got a self-contradiction. So let's look at an example here, and we'll try to determine whether this statement, P and, not P and Q, is a tautology or a self-contradiction. All right, so start out by doing this. So I got two component statements, P and Q, and these four rows cover all combinations of truth values for those two statements. Okay, so once again, when I'm making my truth table, kind of write my statement down, space it out a little bit, start inside the parentheses, not P. So we're looking here, false, false, true, true. So remember, that's going to have the opposite truth values of what we have in the column for P. And then this is going to just be the exact values that we have in the column for Q. So we did that first, and this was our second step. And now we're going to apply the AND operator to these two columns. Now remember, the AND operator only gives a true when they are both true. Okay, so this third row here is the only place I have a T, because that's the only place the two input columns have T's. Okay, I'm going to copy down P again. Remember, I worked in here first because of the parentheses. Okay, so now I'm looking at column 4 and column 3 right there, and I'm going to complete this operation on this column. It's an AND operation. So remember, AND will only give you a true if both of the inputs are true. So here I have true, false. So output is false. True, false. Output false. False, true. Output false. False, false. Output false. Okay? So this is the truth table for P and, not P and Q. So that column is all false. So this is a self-contradiction. All right, so if this column had been all true, then I would have had a tautology. If it was a mix, then it's neither a contradiction nor a tautology. All right, so to determine whether you have a tautology or a self-contradiction, look at the truth table. All T's, tautology. It's easy to remember. Right? If it's all T's, it's the one that starts with a T, tautology. If it's all false, contradiction. If it's a mix, then it's neither of the two.